Somewhere deep in the silence of space, a signal was detected that didn't fit any known pattern. At first, scientists thought it was interference or a glitch in the data, but the more they studied it, the stranger it became. It pulsed with a rhythm that didn't match natural cosmic sources like stars or pulsars. It wasn't random, it looked structured, and that's what made it unsettling. Because in science, structure usually means intelligence. The question that followed changed everything. If something out there is sending signals, what exactly is trying to reach us, and why now? Today we will talk about this signal from space terrified scientists. So before we start, make sure to hit the like button and subscribe to my channel. 1. The moment a routine scan turned into a global mystery. In the world of radio astronomy, thousands of signals are collected every single day from telescopes scanning deep space. Most of them are predictable. Pulsars spinning at steady intervals, background radiation left over from the Big Bang, or emissions from distant galaxies colliding. But during one routine observation cycle, something unusual appeared in the data stream that immediately disrupted normal analysis. Patterns. The signal was narrow, unusually clean, and carried a repeating structure that did not match any known cataloged cosmic source. At first, the team assumed it was a calibration error or interference from Earth-based communication systems. However, when the same pattern reappeared during independent scans, the possibility of a simple mistake began to disappear. 2. Why the signal was so disturbing to scientists. What made this signal especially unsettling was not just its presence, but its precision. Natural cosmic signals are usually messy. They scatter as they travel across millions or even billions of light years, losing clarity along the way. Yet this signal showed an unusual level of coherence, almost as if it had been transmitted with intent. The waveform appeared structured, with repeating intervals that suggested periodic encoding, rather than random emission. Some early analyses compared it to known phenomena like fast radio burst events, but even fast radio bursts tend to be chaotic and non-repeating in most cases. This signal, however, hinted at consistency. That consistency is what triggered concern, because in physics, structure often implies a source that is either highly unusual or artificially generated. 3. Cross-verification across multiple observatories. To rule out equipment malfunction, multiple radio observatories were contacted to verify the detection. Facilities similar to those used in large-scale sky surveys, including arrays modeled after systems like the former Arecibo Observatory and modern distributed telescope networks, compared their data sets. What they found made the situation even more intriguing. Traces of the same signal pattern appeared in independent recordings, taken at different locations and times. This ruled out a single hardware error or isolated interference event. Engineers checked satellite logs, atmospheric conditions, and even solar activity reports, but nothing matched the timing or structure of the anomaly. The more teams tried to eliminate natural causes, the more persistent the signal became in their datasets, forcing scientists to consider that they might be observing a genuine astrophysical phenomenon rather than a technological glitch. 4. Historical echoes. The return of cosmic mystery. As news of the signal spread within academic circles, many researchers immediately recalled one of the most famous unexplained detections in astronomy history, the WOW signal, recorded in 1977. Like that earlier event, this new signal appeared narrowband and highly unusual compared to background noise. However, there was a crucial difference. The WOW signal was never detected again, making a one-time mystery. In contrast, this newer signal showed signs of repetition or at least patterned recurrence across observational windows. This difference dramatically increased scientific interest because repetition allows for deeper analysis. Scientists began constructing hypotheses, running simulations, and testing whether known cosmic objects, such as magnetars, neutron stars, or black hole accretion systems, could possibly generate such structured emissions. 5. Competing scientific explanations and their limits. Several natural explanations were quickly proposed, each with strengths and weaknesses. One leading theory suggested that the signal could originate from a highly magnetized neutron star, whose extreme magnetic fields can produce bursts of energy that sometimes mimic structured radio emissions. Another possibility involved gravitational lensing, where massive objects like galaxies bend and distort radio waves, potentially creating repeating or mirrored patterns. Some researchers also explore the idea of overlapping signals from multiple astrophysical sources, aligning in a rare coincidence. However, each explanation struggled with at least one major flaw, either failing to fully reproduce the signal's structure or not matching its observed timing consistency. This left the scientific community in a cautious but unsettled state, where no single model could fully account for the phenomenon. 6. The psychological pressure on the scientific community. Beyond the technical challenges, there was also a psychological dimension to the discovery. Scientists working on deep space signal analysis are trained to remain skeptical and methodical, but unusual signals naturally trigger curiosity and, at times, anxiety. The possibility, however remote, that a signal could be artificially generated introduces a profound shift in perspective. It forces researchers to confront questions about intelligence beyond Earth, even if such conclusions are not supported by evidence. This tension between skepticism and imagination is why institutions like the search for extraterrestrial intelligence, SETI, emphasize rigorous verification protocols before drawing conclusions. Even so, researchers admitted privately that the signal's behavior was unusual enough to demand continued monitoring. 7. Continuous monitoring and the search for repetition. After initial detection, telescopes were reoriented to continuously monitor the region of space where the signal originated. Advanced arrays performed long-duration scans, collecting terabytes of data in search of repetition. Scientists analyzed frequency stability, polarization patterns, and temporal spacing to determine whether the signal followed any mathematical or physical law. So far, results have remained inconclusive. Some datasets show faint echoes, while others show complete silence. This inconsistency adds to the mystery, suggesting that if the signal has a source, it may be intermittent or influenced by unknown cosmic conditions. Researchers continue to refine detection methods, hoping that improved sensitivity might reveal patterns previously hidden in background noise. 8. What this signal means for the future of space exploration. Regardless of its ultimate explanation, this signal has already influenced the direction of modern astronomy. It has highlighted gaps in current understanding of deep space radio phenomena and emphasized the need for more sensitive, globally connected observatories. Projects involving next-generation instruments, such as expanded radio telescope arrays and AI-driven signal classification systems, are being developed to better identify and interpret unusual cosmic data. Most scientists agree that the universe is far more complex than current models can fully describe. Whether this signal turns out to be a rare natural event or something entirely new, it serves as a reminder that space still holds unanswered questions. The feeling of terror among scientists is not fear in a literal sense, but the realization that the universe may still contain phenomena that challenge the boundaries of known physics and human understanding. Now, if you like this video and would like to see more like it, please give it a thumbs up, leave a comment, and click the button to subscribe.